In this video, I'm going to cover 15 bash or shell scripting tips and tricks slash best practice. Welcome to the channel. If you're new here, please consider subscribing. We cover infrastructure as code, scripting, cloud, Kubernetes. Let's get on to the tips. The first one is, if you've got arguments for your script, then always validate them. So in this example here, what we're saying is, if no argument was provided, then echo to the user something useful. In this case, it's actually mentioning, this is nice, the file name, and then argument, and then exit with an error code of 1. So this is a very graceful way. If someone forgets to put in an argument, then they'll get this message. Another one is, if you're using external commands like awk or sed or something else, then it's good practice to make sure to check that they exist first. It's just more graceful. So there's a few ways to do it. Command -v is probably the most common and the best way, and this is an example of how to do it for Git. And if Git's not installed, then it will echo such a message and then exit the script with an error code of 1. And another nice thing to do is to use set commands. Not all are good, but some of them are, and I like to have set-e, and it means that while you're developing your script, if there's any error, then it will immediately execute the script instead of going on and executing the rest of the script and probably producing even more errors, and then you're frantically trying to Control-C and break out of the script. If you use set-e, you shouldn't have that problem. The first error, and it will immediately exit. Another set command that is good is set-u, and what this means is, let's say your code, it refers to a variable, it does some manipulation on that variable. Well, what if you forget to set a value for that variable? Then if you use set-u, then it will tell you, it will fail. So it's a good way to make sure that you actually set values for your variables that are then later on used in your code. When you're happy and the script is finished, obviously take out this set-u. It's generally good practice to quote your variables, and by that I mean put these double quotes either side of your variables. In this case it's $1. It's just safer, as it says. Sometimes you'll get away with it, like if that variable is a number, then no big deal, but in other cases, if you're using words and spaces and wildcards and stuff like that, then it won't work as intended. So better just get in the habit of quoting your variables. And again, kind of similar, you should do the same thing for conditionals. You should use these double square brackets instead of singles. In simpler cases, it might work all the time if you only have singles, but it's just better to use doubles. It's safer, it's more powerful. There's actually more options for conditionals as well. Just get in the habit of using doubles. It's much better. Now, CD in scripts is generally not advised, but if you're going to use it, and sometimes you're forced to use it, like for example, there are some installation scripts you might be forced to use CD to traverse and navigate through different directories. If you're going to use it, then at least have a check. So in this case, this is a check, and what it says is it'll echo a message and exit with error code 1 if it wasn't successful. Now sometimes, and very often actually, in scripts you need to have temporary files, and a really nice way to do that is to use maketemp. So there's an example here where maketemp is used, and actually it's used further on. It's actually, there's a variable assigned, and it actually refers to the file name. So maketemp is really nice. It'll create a unique temporary file in your /tmp directory, which is where you should put them, and it's empty by default. It's just a really super handy command, maketemp. Saves you having to make your own. Now trap is really good. When you, let's say you have temporary files, as we just mentioned earlier, or something similar, and you want some cleanup to be performed after, at the end of your script. Well, what you might have done so far is just put a remove force of the file right at the end. But the problem is, if something goes wrong, then this might never get executed. So what you should do is, after the temp file is created, you should actually put this statement here. And what this says is, it says that when the script exits, whether due to a normal situation or even due to an error, but when it exits, then remove the temporary files. So this is super nice, and it means that if you have an error that you weren't expecting, then it will still remove those temporary files at the end. It won't leave them left over. Another one is to avoid hard code. If you have a path, avoid hard coding it. Instead, use a variable like we've done here, or even an environment variable, and then later on you can refer to it like this. So just generally with paths, the first thing to do is assign it to a variable. Constants can be useful in programming. A lot of modern programming languages don't even have the concept of constants, but they're still very useful. If nothing else, for clarification, what you're doing is you're telling someone using your script that this value of this should not be changed. So you can do that in Bash shell scripting. You can say read only, and then here is your quote-unquote variable with a value, and it's saying to the user, don't change this. But it's also, if they try to change this later in the script, they got somewhere in their code where max_retries attempt to change that value, it won't be able to happen because you put this prefix read only on it. It effectively locks this. Of course, they could go change it here where it's originally defined, but hopefully they won't do that because it quite clearly says this is read only. If you have got repeated logic, use functions. I think everybody is used to this. This is something you'll do very commonly in modern programming languages like Python. But in Bash, most scripts tend to be quite a limited, low number of lines. Actually, most of the time you don't really need functions, but if you do have a lot of repeated logic, then it is a good idea. Here's a classic use case. Let's say you have different files for different scripts for different environments, like you may have dev, non-prod, prod.shell, and in there you've got very common logic, but you were forced to have a single different script for each environment. And what you can do is you can actually have a function that encompasses most of that common logic, and you can even put this function in a separate file. I like to call that a library file, and then in each of those three environment scripts refer to the file that contains the function, common function to all of those scripts. That's a nice way to do it. So this is one of those cases where for command substitution you can have a few different ways of doing it. It's just considered much better practice to use dollar and brackets like this. So for example here, in the case of using date, don't use backticks. Backticks can cause issues. You may need to use escape characters and stuff like that, and you can also, it's more powerful to use dollar bracket. You can do a lot more with it. You can sort of embed one within another. This is a little bit more advanced. It's very similar to the first example we had, where if you forgot to put the argument to the script, then you can, even if you want to have a -- help and have a really advanced multi-line sort of almost like a help document. This is great if you have like a script that is used commonly by many team members and it does quite a lot. Then it's at that stage, more complex script, you might want to think about having a help message in there. And then finally, it's a good idea to check your scripts with shell check. This is really cool. It's kind of like a linter, but more than that, it offers some really solid advice. And you can install this locally on your laptop. This would be the command, and this is how you run it. You just use your script as an argument to shell check. If you go to shell check website as well, there's actually an inline web form. If you wanted to, you can copy and paste it there. You could even use shell check in a CI/CD pipeline. So there's lots of ways to use it, but yeah, very simply you can just use the web form or just run it locally. It is a super cool program. So that was 15 tips and tricks, best practices for Bash shell scripting. If you haven't already, please consider subscribing to the channel. As I mentioned, we cover infrastructure as code, primarily Terraform, also scripting, Bash, Python, also cloud, multi-cloud, and Kubernetes as well, and other kind of basically thoughts I might have about DevOps and stuff, cloud DevOps. Please consider subscribing. We're growing, and I will see you soon. Bye-bye.